Well, good morning. Wanted to do just a quick video on the latest piece of gear that arrived. I've been after an isolation transformer for a while to help with the calibration of the 415Es. Those are very sensitive, or up to 60 dB amplifiers effectively, and they're very, very sensitive to ground loops and things. And they talk about it in the manual. And so I've been after an isolation transformer that would help me ensure that the equipment under test isn't affected by a ground loop. And these are apparently very well respected isolation transformers. And this is the Sencore model PR57. And so basically what an isolation transformer is pretty much a one-to-one transformer from the mains to the output, and it utilizes that that transformer to effectively break the loop between the current that will be in the item under the isolated output and how it is referenced to ground. So, you know, the original idea was that a lot of older equipment, like old radios and so on, would have live chassis and a lot of live voltage hanging around. And so by utilizing an isolation transformer, you could effectively take that equipment and keep it isolated, so that if you touched the chassis by accident, you weren't actually creating a ground path and getting yourself electrocuted. So that was sort of where these things came from. And this one was on eBay, and I picked it up. Quite inexpensive, to be honest. And I'm very happy with it. So I just got it here. I'm very happy to purchase it. So I got it here. So let's take a look at what the unit does, and then we'll pop it open and take a look inside. So the first control here is the line voltage. Let me turn the unit on. And what you can see here is on the meter, it's reading what is the voltage actually in my line here. It's morning, so the drink of choice is a coffee. So what we're reading there is about 116. Let's set our meter up and go and look at AC volts here, and we'll just you can see that there. So let's put our probes into the socket. I don't recommend this. It always scares. I'm a digital. When I did engineering at university, I did digital stuff. VLSI design was actually my fourth year thing, and power always scared me. You know, I'm a firm believer in the statement that if God meant you to play around with it, He would enable you to put your tongue across it. So anyway, you know, we're reading about 116 volts there, and we're reading about 116 on here. So in terms of the line voltage, that's pretty damn accurate. Now the next thing you can do is, you know, the isolation transformer of one-to-one winding would give you just, you know, 116 in, 116 out. But seeing you're putting a transformer in there, you can actually create or create a variable transformer. In fact, a thing called a variac, and variac is a brand name, I believe. But the concept of having a variable transformer, and so you can do that here as well. So if I select the output voltage here, you know, we'll see that we've got a gain around 116. So let's just drop that in there and bring this back into shot. There you go. So about 116. But I can transfer that down, you know, and scroll this down and say, let's say 50 volts there on the little display, and you'll see 50 volts on the meter. That's pretty damn accurate. So, you know, if we go down further, we can come right down to, you know, 10 volts AC. And again, so the linearity of the meter is pretty good. and we can drive this. Now, the reason you use this is that a lot of test gear, especially the older test gear and in the vintage era, would talk about the power supplies, and part of the checking of the regulation of the power supply was being done correctly by starting with a lower input voltage and slowly bring it up, and watching the regulated voltage supply to make sure that within the bounds that it would talk about. So it might say from 90 volts AC to 150 volts AC that the regulated output should be 22 volts. And so the calibration procedure to check that everything's working would say set the input voltage on a variac to 90 volts, put and check the regulator, set it to 140 volts, check the regulator. And so that's what you would use this for. Another thing that you can use this for is the suggestion that in a lot of older gear, especially gear that has been is tube based or has had electrolytic capacitors have been hanging around for quite some time without running, you can turn them on, plug them in, turn them on with the voltage down, and then slowly increase the voltage on the device, and that will help the capacitors reform and not blow up or explode. I don't know how true that is. Again, I'm not a vintage radio guy, so I'm assuming that it's true and there's a universal wisdom to it. But you can do this and slowly bring your device up to operating temperature and operating power by simply using this variac. Now, you saw that I had 116 in there. We can go a little further, and the total unit can output 145 volts off that 116 input. So that's the variable part of it. Let's take this stuff out here. Now, I could plug in some equipment, and these two items here give me the ability to measure the power on the 175 watt scale or on the 470 watt scale, and you can see the little lights as we come down through it. And then what we can do is measure how much power is being used and get an idea of the amps and so on. This will drive a continuous load of 3 amps. It has, if you look down here, it has a 4 amp slow blow fuse in it, and then this circuit breaker here will trip prior to that 4 amp. It should trip if it gets a large surge or so on, and that will effectively turn off the unit, and then you can reset it. So you should be able to be protected by the circuit breaker here before you blow the fuse at the back of the unit. Anyway, these things here will tell 0 to 4 amps, 0 to 1.5 amps, to give you the granularity to see how much power is actually being used. One of the things that you can also use this particular model for is this concept of leakage, and this is being able to detect how much power is leaking from the unit to certain parts of your circuit with respect to each of the the high and the low side of your AC voltage. Now, these things have a probe, and you would plug this probe into the unit here, and then you could go and search for the probe. I have never seen the original probe on sale, and pretty much these things don't come when they're ever sold. They're sold without the probe anyway. You can go on eBay, and there's at least one guy there making adaptable probes for the unit, so you can get that and do that testing. Now, I'm not particularly interested in the leakage. I was more interested in the isolation. So, what does that mean in terms of of how you're protecting the user here? Well, if we come in and we turn the unit back on and we look at the output voltage, and we're going to say that, let's put this in, that's 117 volts. That's going to be enough to kill you if you touch that. And if you were to go and say take one of these outputs and ground it, you would see a current flowing through that output. What we can do here, though, is the isolation transformer removes that reference to ground and removes that direct current path. So if I come over here and actually ground my probe on one thing, you'll see that there's a 70 volt difference in the voltage here. But that voltage isn't important. What we're actually looking at here is the amount of current that flows. And so if I was to now put this on here, if this was just simply a power outlet and grounded it, I would see a massive amount of current would flow through, and we would see that sparks would fly and so on. But what we're seeing here is that there's really only 3 milliamps, and not even that, of current, a milliamp of current. Let's go back to the milliamp range. See, and that was really just phantom voltage, phantom values from the meter. There's no current is flowing through that circuit. So that means that if I had the unit plugged in here and I accidentally touched something, I wouldn't ground myself, and so I shouldn't get a shock on that. The other thing that it means is that when you're probing with an oscilloscope, you can be more assured. It's not completely safe, so you still need to pay attention to what you're doing, but you can be more assured that as you're probing stuff, that you're not going to suddenly put your oscilloscope in an AC power circuit and blow the front end of your scope up. This will help protect you from that, because remember, the ground on the scope is actual tied to ground, and so if you're probing high voltages, you will get you just put a 1 mega ohm resistor across that voltage, and it could induce a substantial current in the device. So, or a 50 ohm if you're a 50 ohm scope. So that's another thing that these units are going to be good for. So anyway, I've prattled on now for quite some time about this unit. Let's take a look inside and see what the unit looks like. Okay, well, it seems that there are screws on the side will hold in holding in those lids there. So let's grab a screwdriver and let's take the screws out and see if that lets us take the lid off things. Now these things are not electrically very complex. I printed out the schematics so that we can take a look at that when we're when we have the top off. But when you actually look at the units, you pretty much have mains input, variable transformer output, and then you have the rest of the circuitry is there simply to monitor or drive the front panel meter. So we can the actual, if you didn't need the front panel meter, there'd be virtually no actual electronics needed inside the unit. So there we go. So let's take that side off, and have that side off there. And here you can see what I'm talking about. If you look inside, there's virtually nothing. There is the transformer, there is the variable the transformer winding at the front there, and then here's the meter, and then under this can here is where the electronics are. So let's flip that round and just take that top off. Okay. Okay, and so now we take that top off, and there we go. You know. So that is pretty much everything that's in there. Let's see. Let me tilt this up and see if I can take that little can off there, and then we can maybe look at the circuit board. I don't know if that can come off or not. I don't know if can I get that out? Okay, let's just carefully take that out. There we go. Okay, so pretty much it's exactly what I was talking about there. Let me grab my pointy stick, have some more coffee. So here you have the mains coming into the unit. We have the primary transformer and then the variable power transformer there, and that's going to be, you know, as you turn that, you'll see the little bar move as it winds across there. Now that's exactly how, you know, the variacs that you've probably seen, which are the big black, grey things with the knob on the top, that's pretty much exactly what they're doing. They're a set of windings in a transformer, and that little brush just spins across the top of that winding, and wherever you've set, it basically is providing an exit to the transformer so that you have a variable number of windings based on where that is, right? And so that's there's your circuit breaker is in under there. And I talked about how there's virtually nothing when it comes to the actual meter itself. There's the meter movement, and it's plugged onto the board here. And you can see that we have some current shunts or sense resistors around that are going to give us a voltage based on the current that's coming out of here. Here are these little push contact switches that we had on the front. And then there's going to be these little trim pots for you to set when you do calibration. So let's grab the circuit diagram, and you can see exactly that. It really isn't very complex at all. Let's go and knocked over my IPA. Let's just drop this back in here so that we can lay the schematic down here, and let's zoom in a bit so that you can see the schematic. Pretty much, you know, you're going to have, you know, if you ignore this part of the schematic here, what you're basically doing is, you know, you're bringing your power plug into here, coming through the breaker, you know, that we saw, into the variable winding, and then into the one-to-one transformer. That then, you know, you've got one half of your power coming out, going to the isolated socket, and your other part basically comes through here, through this 22 watt resistor, across here, and connects straight back into the meter, into the other side of your power. So it comes through this 22 watt resistor there, all the way straight through, and connects back up, and that's all you've got there. Then the rest of the circuitry that's down here is either about driving the LEDs that were in that meter, you saw that as they came down the side, or the electronics to drive the actual meter movement itself. The rest of this, you know, is pretty much just selecting what is going to the actual meter display. And that's it. They're very simple devices here. And you can see that we have the calibration trim pots around to enable you to calibrate, you know, the output voltage or the input voltage readings. You might have to have a look. I think it's probably output voltage reading. There's a calibration over here for the meter movement to, I'm showing linearity. There's calibration up here for leakage current. Because remember, that was the leakage part of the circuit here. And we talked about those made up probes. They're not really that hard to build. If you look at it, all it is, the probe is basically this 135K resistor with in parallel with a push button. So when you're probing around to see where stuff is, you're going to have that 135K resistor in series. And then when you're ready to go and measure the leakage current, you're going to push the button, and that basically shorts that resistor out, and then it's going to tell you what the leakage current is by reading the voltage across the calibration and the 10K resistor inside here in that leakage circuit. So there's really not a lot of complex electronics to it. So we've taken a look at what's inside the unit here. We've taken a look at its operation, and I'm going to go reassemble this. Hope you found that interesting. Catch you later. Bye.